Hi students, and welcome to this lecture on limits. This picture denotes the limit of the cliff. It could also mean the limit of craziness of this boy. But as we are studying mathematics, so we will talk of limits in mathematics. In mathematics, the concept of limit is used to describe the value that a function or sequence approaches as the input or index approaches some value. Limits are so much essential in the study of calculus and are used to define the concepts of continuity and differentiability. Differentiation uses limits to find the general gradient of a curve and thus is used to calculate rate quantities like velocity, acceleration, rates of reactions, and so on. Similarly, integration uses limits of the sum of the areas of hypothetical strips bounded by the curve to find the total area bounded by the curve. Now this is used to calculate the volume of solids, areas of plane figures, and so on. So we see that limits play a very important role in calculus. So without wasting any time, let's start this lecture. Now let's start this lecture with the introduction of limits. Let me say that y equal to fx is this function. This very function denotes y equal to fx. Now for x equal to a, the value of y equal to fx is f of a. Now if I take any point on the left side of a, that is a minus h, where h is any positive number, then the value of y equal to f of a minus h is equal to f of a minus h. And similarly, if I take a point to the right side of a, that is a plus h, then the value of y would be f of a plus h. Now when h tends to 0, a minus h is a point to the left of a. Now if h is very much close to 0, then a minus h would be very much close to a. That is, it is just very close to a. It is almost touching the point a. And similarly, a plus h is a point to the right side of a. So this point is just to the right of point x equal to a. If I say that f of a minus h is equal to f of a plus h, that is, this value is equal to this value, then if x tends to a, fx would tend to f of a. F of a minus h is equal to f of a plus h, then I would say that limit exists, and if x tends to a, f of x tends to f of a. Now let's define what is limit. It is defined this way, that is, if x tends to a, limit of fx is equal to L. Now as we approach the point x equal to a from the values which are just smaller and just greater than x equal to a, then fx moves closer and closer and closer to the value L. If I say that x tends to a, fx would tend to the value L. Now mathematically we can write it as modulus of fx minus L is less than epsilon for all x, such that modulus of x minus a is greater than 0 and less than delta. Your epsilon and delta are very small positive numbers, and the value of epsilon depends on the value of delta. So we have seen that fx is not exactly equal to L, but it tends to L, so that fx and L are very close to each other, or the modulus of fx minus L is less than epsilon. We have taken epsilon, a very small positive quantity, and similarly x tends to a, so the modulus of x minus a, or the magnitude of x minus a, is greater than 0 and it is less than delta. Now delta is also a very small positive number. Now let's try to understand it. This is y equal to fx. Now its value is equal to L at x equal to a. Now if I take any point that is delta units within x equal to a, then the value of fx would be within epsilon units of L. So that if I take any point at delta units, then the value it assumes is L minus epsilon, and that is very much close to the value L. Similarly, if I take any point x equal to a plus delta, then the value would be equal to L plus epsilon. Now L plus epsilon is also very much close to L because epsilon is very much close to 0. Now for limit to be defined, it is important to note that fx must be defined in the neighborhood of x equal to a, not necessarily at x equal to a. Now this is a very important point to note. fx has to be defined in the neighborhood of a, that is a plus delta and a minus delta. It's not necessary that it should be defined at the point x equal to a. Now let's try to understand this point. If I take any function fx equal to x square minus 1 divided by x minus 1. Now fx is not defined at x equal to 1. Now if I put x equal to 1, then this will be in the indeterminate form. Now let's try to take values of x which are very much close to 1. So let us say that I take x equal to 0.9. Now the value of fx is equal to 1.900. If I take x equal to 0.99, that is more closer than 0.9. So the value of fx is equal to 1.990. If I take x equal to 0.99, that is very much close to 1, then the value of fx is equal to 1.999. At x equal to 1, it is undefined. Similarly, if I take values of x which are just greater than 1, that is if I take x equal to 1.001, then we can say that the value of f of 1.001 is equal to 2.001. Now this is very much close to 2. Now f of 1.01 is equal to 2.010 and f of 1.1 is equal to 2.100. So we see that the values of fx tends to 2 when x tends to 1. So we can say that when x tends to 1, the value of fx tends to 2. And it is not necessary for fx to be defined at x equal to a, but should be defined in the neighborhood of x equal to a. Now we have seen that at x equal to 1, this function is not defined, but in the neighborhood of x equal to 1, it is defined and its value is very much close to 2. Hence we can say that limit x tends to 1, f of x is equal to 2. Now let's try to understand what is left hand and right hand limit. Now the left hand tendency of fx at x equal to a is called as the left limit, and it is denoted by f of a minus 0 equal to limit h tends to 0 f of a minus h. Your h tends to 0. H is a positive quantity and it is very much close to 0, and we are taking the value x equal to a minus h, that is very much close to x equal to a, and value of function f of a minus h when h tends to 0 is called as the left hand limit. Left hand because the point x equal to a minus h lies to the left side of point x equal to a. Similarly, we can define right hand limit as the right hand tendency of fx at x equal to a is called as the right limit. Now it is denoted by f of a plus 0 and is equal to limit h tends to 0 f of a plus h. Now again we see that h tends to 0, that is h is a positive quantity and whose value is very much close to 0. Now a plus h is a value which is very close to a, but it is actually greater than a, or the point x equal to a plus h lies to the right side of the point a. So the value of f of a plus h is called as the right hand limit when h tends to 0.